Hi friend, welcome back. This video is about Mosfet, how to protect, use and run them safely. MOSFETs are widely used for switching purposes. In general, the MOSFET works as a switch, controlling the voltage and current flow between drain and source. I will give more detail about that later. MOSFET is a field effect transistor, meaning that controlled by voltage, not like a BJT, which controlled by amps. The working principle of a MOSFET depends on a capacitor getting charged or discharged. Each capacitor is rated for a maximum voltage that can be dropped across it. Exceeding the maximum voltage will result in destroying the capacitor. In MOSFET, that voltage is called VGS and it's vary between 30 to 30 volt from one MOSFET to another. See your MOSFET datasheet before using it. Now we know the MOSFET gate is sensitive for voltage. The best option to protect it is a Zener diode connected in reverse bias. The diode voltage depends on the MOSFET VGS. I'm using a 13 volt Zener diode for all my MOSFETs. Now we protected the MOSFET from overvoltage and we know the gate is a capacitor. As you know, capacitors store energy. If you want to use the MOSFET for high frequency, there will be delay in turning off. Discharging a capacitor is simple. Use a 10K resistor with a Zener diode in parallel. Protection for the drain is necessary too. Most switching applications are for inductive load, which all inductive load create voltage spike, which may damage the MOSFET. My advice is a snapper network or a simple diode across the inductive load. To use a MOSFET, go to the datasheet and search for these values first. These values are important for the next formulas. That's an example with a 10 amp load. If this formula is bigger than this one, use a heatsink. Now I have the full setup to test the MOSFET at here. This load has a resistance about 20 milliohms, according to this calculator, and it's drawing about 18.5 amps. Now I connected the load in series with the MOSFET and put an amp meter on the MOSFET gate. Here is the schematic. The reason for why this is happening is the gate voltage. When the MOSFET turns on, it will draw a large amount of current, which will cause a voltage drop. And because the gate voltage is from the same power supply, it will drop too, causing a high resistance between drain and source. The solution for that is a capacitor bank. The only problem is this. Solution 2 is another transformer to supply the MOSFET gate. Remember to connect both power supply negative together. The MOSFET works perfectly. That's it for this video. Thanks for watching.